Alright, here is what is known as a two-body problem. So basically, this person is pulling on rope B, right here, with a force of 90 newtons, and they're dragging two objects along. And the common misconception one person likes to think is, oh, if he's pulling rope B with 90 newtons, that rope A will have the same force on it. And that's not something that's entirely true, which we'll find out momentarily. So the key thing to a two-body problem is there are three things you can analyze. You can analyze each individual body separately, or you can just pretend that they're all tied together in one big unit. So that's what we're going to do first. We're going to analyze what's called the system. So when we analyze the system, we say, all right, what is the mass of the entire system? And in this case, it's 30 kilograms, because the two blocks together are the entire system. We say, what force, net force, is acting on the entire system? Well, the person is pulling rope B, and that is the force acting on this whole system. The rope is part of the system, so it doesn't count. Rope A, that is, we're going to ignore that. So the net force on the entire system is 90 newtons. So then we can calculate the acceleration of the entire system. So it's, F net over mass, or 90 newtons over 30 kilograms. So the entire system is accelerating at 3 meters per second squared. Alright, so that's the acceleration of the system. Now we want to find the tension on rope A. So this is where we actually break it up, and we don't just look at the system anymore, we look at a specific block. In this case, I'm going to pick block 1. So I'm going to analyze block 1 as its own mini-system and analyze what forces are on it. So here's a picture of block 1, and we know it has a weight. We know there's a normal force, which will cancel each other out. It's not sinking or anything. And rope A is pulling it along, and that is the only force acting on it, the only net force acting on it is rope A. So block 1 has a mass of 10 kilograms. We currently do not know the net force acting on block 1, but we know the acceleration of block 1 is 3 meters per second squared. And how do we know this? Well, because the system is accelerating at 3 meters per second squared, and block 1 is part of this system. It is all moving together. So knowing that, we can now find the net force, because we know that the net force is mass times acceleration. So 10 kilograms times 3 meters per second squared. The net force on block 1 is 30 newtons. And if that's the net force on block 1, and the only real force that's not being canceled acting on block 1 is FA, or TA, the tension of the rope, then the tension of the rope is in fact 30 newtons. But let's double check this, and the way we're going to double check it is we're going to analyze block 2. So block 2, if we analyze, has a few more forces acting on it. So block 2 has, again, the weight and the normal force, which cancel, but it has the force you're pulling with, 80 newtons, and it has this force back from the rope, which we're going to pretend we do not know right now. So block 2 had a mass of 20 kilograms. It also had an acceleration of 3 meters per second squared. So its net force, again, m times a, is 60 newtons. So the net force acting on block 2 is 60 newtons. Alright, I made a slight mistake here. This should be 90 on this diagram. 90 newtons is the forward force on the block. Alright, so the net force is 60 newtons on block 2. So if there's 90 newtons accelerating it forward, what is this tension force pulling it back? Well, to make a net force of 60, that's going to have to be 30 newtons. So hey, how about that? The tension in rope A, we once again showed was 30 newtons. So they're the same answer, which we expect. Because from the third law, block 2 pulls on block 1 with a force of 30 newtons. So this rope pulls block 1 with a force of 30 newtons forward. The reaction force is that block 1 pulls block 2 back with a force of 30 newtons. So these should always be the same. The tension on the rope should be the same for each. And that's one good way of checking this answer. So that's what we've solved. We found the acceleration for the system and the tension, and we did it two ways. We confirmed it was the same in both cases, which is often good to do if you have the time. So that's a two-body system. It's certainly more complicated than things that we've done before, but just break it down. Always consider what you're analyzing, and it should be all right. So until next time, I am Derek Genova. Have a delightful day.